Okay, in this video we're going to be looking at quadratic functions and specifically how to take a quadratic function that's in standard form, which is this first line we have here, and turn that into vertex form, which is the second line that we have. Hold on, get my pen to work. Here, standard form. So if we're given a quadratic function that looks like this, we want to be able to turn it into vertex form, which would be a function that looks like that. So I'm going to show you two different ways. The first one is completing the square. So we did learn how to complete the square back in our unit on quadratics. So it works very similar to the way we did it there, just a little bit different because we don't have 0 over here on the left. We're not solving. We have a variable over here. But again, very similar process. So there's a couple different ways you can do this, but I'm going to show you my preferred method. I like to move the constant over to the other side so that on the left I have f of x minus 71. And when I rewrite this, I'm going to leave a blank because I'm going to be adding something to both sides of this equation. And then over here on the right, I'm left with just my terms that have x's in them. Okay? Anything that doesn't have an x goes on the left. Any term that has an x value goes on the right. And when we complete the square, we need to add something to both sides, and that something is b over 2 squared. So in this case, our b is 16 over 2, that's 8, and 8 squared is 64. So we need to add 64 to both sides of that equation. Then in our next step, on the left, we can combine those two constants that we have. A negative 71 and a positive 64 leaves us with minus 7. And on the right, we now have, by design, a perfect square trinomial. That's the whole purpose in completing the square. So that's going to be x plus 8 quantity squared. The square root of your first term gives you your first piece of your factoring, and the square root of your second term gives you your second piece, and the sign gives you your sign, the sign in the middle. So then the only thing left is to take this 7 and put it back to the other side. So we'll add it. So our quadratic function in vertex form looks like this. And let's compare that to the formula for vertex form. Okay, because that's how we're going to figure out what our vertex for this specific function actually is. Notice that our a value in this case is 1. We don't have a coefficient there. Notice the formula actually asks for x minus h. We have x plus 8 right here. So what that means is what we really have going on inside there is x minus a negative 8. So that negative 8, that's the x coordinate of our vertex. Plus k, we match that exactly, plus 7, so 7 is the y coordinate of our vertex. So you'll notice what it ends up being is the x coordinate is always the opposite of whatever sign you have right here in the middle, and the y coordinate is always the same sign that you have here. And it's just because of that negative sign in the vertex form that's part of the formula. Okay, so let's look at another example. We're going to go ahead and graph this one too, just for good practice. Okay, so first up, we're going to put it into vertex form. This one's a little different because we cannot do completing the square when there is a number in front of your x squared. We need that coefficient to be 1. So we're going to have to take an extra step in here to take care of that. So we'll start off the same way. Move the 5 to the other side. And I like to leave a little space over here to write my term that I'm going to add to both sides just because it saves me from having to rewrite it so many times. Now on the right-hand side, when we have these x terms, anytime you have a coefficient in front of your x squared term, you need to factor that out front. So that's how we'll handle it. So we complete the square. We pull that constant out front, factor it out so that now we do have a coefficient of 1 on our x squared term. And what we need to add into this blank is again b over 2 squared. Our b is negative 2, so negative 2 over 2 is negative 1, and we square it, and that gives us positive 1. But here we have to be careful. This positive 1 is inside a set of parentheses. That means we haven't just added positive 1 to this side. We'd have added positive 1 times 2. That's what needs to go into this blank. Because whatever's inside that parentheses is affected by the coefficient out front. So when we put a 1 inside the parentheses, what we've really added is a 1 times 2, which is a 2. Once that step is done, that was the tricky part, then we do the same as the last example. We will combine our constants on the right, on the left, and we will factor on the right. Again, this by design is a perfect square trinomial. And then last step would be to move that 3 back over to the other side. So here is our quadratic function in vertex form. So in this case, our vertex matches the formula exactly. So our vertex is going to be 1, 3. Again, opposite sign and same sign. So that gives us one piece of information if we wanted to go ahead and graph it. The point 1, 3 is right here. And that means we would have an axis of symmetry at x equals 1 running right through that vertex. And then if we wanted to graph this, which we're going to do, we want to go ahead and find our x-intercepts. But if we give this a little thought, we can save ourselves some work, because we know since a is positive 2, that means our parabola is going to open upward, and our vertex is up here already above the x-axis. So we can tell just by looking that we are not going to have any x-intercepts. If we did go ahead and try to calculate those x-intercepts, what we do, we set 0 equal to, I like to use the original form, the standard form, rather than vertex form for finding your intercepts. When we would use the quadratic formula on this, we'd end up trying to take the square root of a negative number, and that can't happen, so that means that there are no x-intercepts. Y-intercepts, that's when we put 0 in for x. So 2 times 0 squared is 0. Minus 4 times 0 is also 0. Plus 5 means our y-intercept is the point 0, 5. About right there. So using the property of symmetry, we know that we have to have a point on the other side of the axis symmetry as well. And maybe we should plot one more point to make sure we can draw a good graph. If we plug in maybe x equals 3. So to calculate that y value, we'd have 2 times 3 squared minus 4 times 3 plus 5. If you plug that all into your calculator, you would get 1. No, that's the vertex. Sorry, you would get 11. Not 1, 11. Makes more sense. So 3, 11 would be right about up here, just a little bit off of our graph. And that means, again, using that property of symmetry, we'd have to have another point over here. And those 5 points give us a pretty good idea. Oops. What our quadratic would look like. If I could draw, you get the idea. Terrible picture, but again, you can see what we're going for here. If you want to have more information on graphing, take a look in our playlist and look at the other quadratic video that graphs several examples. In this one, we're really concentrating on getting your equation into vertex form. Okay, here's one more we're going to do by completing the square, and then I will show you the other method. Again, this one has a coefficient, so we're going to have to factor. We'll start the same way. Take that constant over to the other side. And I'm going to leave a space for whatever I end up adding in here. And I need to factor over here on the right so that my x squared has a coefficient of 1. 2x, if I factor out a 3, becomes 2/3. 2 divided by 3, x, plus whatever I add in here. Don't let that fraction scare you, it's okay. We still have to calculate b over 2 squared, which is 2/3 divided by 2 squared. 2/3 divided by 2, if doesn't come naturally to you, plug it in on your calculator. But that ends up being 1/3, and 1/3 squared is 1/9. Again, be careful here because that 1/9 is in the parentheses. I haven't really added 1/9 to the right-hand side. I've added 1/9 times 3, which is 3/9, or 1/3. Okay, so combine our coefficients on the left. 1 plus 1/3 is 4/3. And we have a perfect square trinomial over here on the right. It's x plus 1/3, quantity squared. Last step is to move that constant back over to the other side. And our vertex form is 3 times x plus 1/3, quantity squared, minus 4/3. Our vertex in this case, opposite sign, same sign. Point negative 1/3, negative 4/3. Okay, and in our final example, I did want to show you another method for finding the vertex form for people who really don't like completing the square. So we have a formula for finding the vertex. The vertex is 2 points. The x value is negative b over 2a, and the y value of the vertex is f of negative b over 2a. So basically, we take whatever we calculated here in the first step and we plug it into our function. That gives us our y value. So we can calculate both of these from the standard form. So here we get negative 36 over 2 times 2, which is negative 36 divided by 4, which is negative 9. And then we take that negative 9 and plug it into our function in place of x. Take that and plug it into your calculator. It turns out to be 8. So using these two pieces, we can build our function in vertex form. So the formula for vertex form looks like this. I had it at the beginning of the video, but I'm just going to copy it down again. X minus h squared plus k. A is always going to be the coefficient of your x squared term. H is the x-coordinate of your vertex, and k is the y-coordinate of your vertex. So we can just fill all of those in. So in vertex form, this function would be 2, that's our a value, times x minus h, so that's x minus a negative 9, x minus the negative 9, that becomes plus k, so that's plus 8. There is our quadratic function in vertex form. Again, the vertex here is negative 9, 8, which is what we calculated up top. So if you really don't like completing the square, you can always use that vertex formula to figure out the vertex and then fill in the blanks on that.